If a centrifugal pump is not completely filled with liquid, that is, if it's not primed, it doesn't have the ability to pump liquid. One way that a centrifugal pump can lose its prime is for air to enter the pump casing, causing the pump to become airbound. There are several ways that air can become trapped inside a pump casing. For example, during startups, the casing and suction piping may have to be vented. If a sufficient amount of air remains trapped, the pump will not operate properly. Another way that air can get into the casing is through a leak. The suction of a centrifugal pump is normally at a low pressure, and this low pressure could draw air into the pump through leaks or the packing. On some pumps, the packing is exposed to the same low pressure that exists at the pump suction. On these pumps, the packing is often supplied with liquid from the discharge of the pump. This liquid cools and helps seal the packing. If the flow of liquid to the packing is not adequate, air could be drawn in through the packing. Air can also get into a pump after maintenance. For example, if piping has been worked on, air in the pipes could make its way to a pump. If the air becomes trapped inside the pump, the prime could be lost. There are several ways to tell if a pump is airbound. One way is to listen to it. A pump that's partially filled with air may produce a rattling noise, similar to the noise a pump makes when it's cavitating. However, the noise caused by air binding may be heard only intermittently. There are other noises that may be associated with air being drawn into a pump. For example, if the pump has leaks on the suction side, you may be able to hear air being drawn into the pump. In some cases, it may be possible to see the flow path for the air being drawn into a pump. With sump pumps, a vortex may form as liquid is pumped from the sump. If the vortex is drawn into the pump suction, it provides a path into the pump. When the pump is partially filled with air, the discharge pressure may vary greatly. Also, on a pump that has an electric motor as a driver, the amount of current drawn by the motor may vary greatly. On the other hand, when a pump is nearly filled with air, the discharge pressure may drop to zero and the pump noise may become a very quiet hum. In this situation, when an electric motor is used as the driver, the amount of current drawn by the motor will drop significantly. A problem that's similar to air binding in a pump is vapor binding. With vapor binding, many of the same symptoms may be noticed. However, the causes of vapor binding are slightly different from the causes of air binding. Vapor binding occurs when a pump loses its prime because vapor has become trapped in the pump. The vapor often forms in other parts of the process and is carried along or entrained in the process liquid until it becomes trapped in the pump. Formation of vapor in a process is affected by the liquid's temperature and pressure. Process changes that increase the liquid's temperature or decrease its pressure may cause vapor bubbles to form and become trapped inside a pump. One condition that causes vapor to become trapped in a pump is suction pressure that's too low. The pressure decrease in the pump's suction can cause vapor bubbles to form. When this happens, the vapor could separate from the liquid and become trapped in the pump. As more vapor collects, the pump becomes vapor-bound and may not be able to pump any liquid. If the liquid temperature is too high, the same basic process happens. The high temperature causes vapor bubbles to form. When this happens, vapor may collect inside the pump, and the pump could become vapor-bound. Venting an air-bound or vapor-bound pump can restore the pump to normal operation. However, this may be only a temporary fix. If there are leaks in the suction piping, if the liquid's temperature is too high, or if the suction pressure is too low, some other corrective action must be taken. Some of the fixes are easier to figure out than others and can be accomplished immediately. For example, if a pump has a packing leak that is drawing in air, then adjusting the packing may stop the problem. On the other hand, if the pump is vapor-bound and it's due to low suction pressure or high liquid temperature, then the way the process is operated may have to be changed. Or the problem may be an indication that a component in the system is not operating properly, and the component might have to be repaired or replaced. In this topic, we looked at operating checks that are commonly made on centrifugal pumps and their auxiliaries. We also looked at how air binding and vapor binding can affect a centrifugal pump, and at some of the methods that might be used to identify and eliminate these problems. Now let's try some practice questions. When packing is used, operators should check to make sure that there is a small amount of leak-off to lubricate and cool the packing. If there's too little leak-off, the packing can dry out and burn. If the packing dries out, the pump should be shut down so that the packing can be replaced. On the other hand, if there's too much leak-off, the efficiency of the pump may be affected. To control the leak-off, the packing must be tightened. This should be done by tightening the nuts on the packing gland one flat at a time. Tightening the gland nuts one flat at a time ensures that the gland does not become cocked. Also, this method ensures that the packing is tightened slowly and helps to prevent over-tightening. There are several ways to tell if a pump is air-bound. One way is to listen to it. A pump that's partially filled with air may produce a rattling noise, similar to the noise a pump makes when it's cavitating. However, the noise caused by air binding may be heard only intermittently. There are other noises that may be associated with air being drawn into a pump. For example, if the pump has leaks on the suction side, you may be able to hear air being drawn into the pump.